Welcome to this video on the Automic Automation GCP Dataflow integration solution. In this video, we will explain the GCP Dataflow integration and what it brings to the Automic Automation user community. Google Cloud Dataflow is a fully managed, serverless data processing service that allows developers to build and execute data pipelines for both batch and stream processing. It provides a unified programming model that simplifies the development and execution of data processing tasks. It works on both batch and streaming data. Dataflow can scale seamlessly to handle both small and large datasets, making it an ideal choice for big data workloads. Integrating Automic Automation with GCP Dataflow allows you to run Dataflow jobs in your workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating GCP Dataflow, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. GCP Dataflow processes can then be synchronized with all other environments routinely supported by Automic Automation. GCP Dataflow's role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log in to the GCP Dataflow environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to run jobs in GCP Dataflow. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of GCP Dataflow jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the GCP Dataflow endpoint and login data, and a job template designed to trigger run jobs. Let's assume we're automating for 4 instances of GCP Dataflow. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the Dataflow run jobs in Automic Automation for each corresponding process in GCP Dataflow. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in GCP Dataflow. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the GCP Dataflow integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. GCP Dataflow is a standard atomic agent. It requires at least 4 values to be updated: agent name, atomic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every GCP Dataflow instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the GCP Dataflow endpoint. Finally, we use the GCP Dataflow template job to create the jobs we need. We match these Automic Automation jobs to the GCP Dataflow run jobs, reference the connection object, and run it. We're able to supervise the jobs and their children, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the GCP Dataflow integration. The agent is included in the GCP Dataflow package, which we download from Marketplace. We unzip the package, which creates a file system agents/dataflow/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the GCP Dataflow run job. In our demo, we will create a connection object. Once we have established the connection to the GCP Dataflow environment, we'll create a Dataflow run job. Finally, we'll execute and supervise the job. Let's examine the GCP Dataflow environment before we look into the Automic system. The major building blocks of Dataflow are data pipelines and templates, as the overview page already shows. Templates allow you to package data pipelines for deployment. These templates have an advantage over pipelines because they enable you to separate the design from the deployment. You can use the pre-built templates that Google provides for common scenarios, or developers can create custom templates, which a data scientist can directly deploy. The Jobs section shows all the jobs we have already run through templates. Dataflow jobs require 2 identity and access management (IAM) accounts to run. The Cloud Dataflow service, which uses the service account to manage Google Cloud resources such as creating VMs, and the Dataflow Worker Service account, which accesses the pipelines, files, and other resources. The minimum roles that the service account must have are for the Dataflow developer or the Dataflow admin to be able to create and monitor the jobs. Now, create a job from a template in the GCP Dataflow environment. We can define various parameters such as the job name, which helps us identify the job we are running, and the regional endpoint. When we open the Dataflow template section, we see that there are already many templates available for defining the Dataflow template. Let's select the template for the word count. Now, you see the required parameters section, which requires you to fill in the parameters specific to this template. You can also define the type of encryption you prefer, and you can provide various optional parameters like the number of workers, the service account, or network-specific data. You can start the job and monitor it. The monitoring section gives you an overview of the running jobs, workers per job, and a lot more. To view a specific job, go to the job field and select a desired file. Here, you can see the graphical representation of the job. However, we can also directly view execution details such as job metrics, costs, and runtime duration. Let's move on to the Automic system. Here we create connection and job objects with specific inputs to connect to GCP Dataflow. If we open a connection object, we must enter the endpoint, which is the URL of the GCP Dataflow environment. Next, we specify an authentication type from the drop-down menu. Currently, we support the service account key, which you can provide directly as JSON or via a file path. We select the file path input type and specify the location of the file that contains the authentication information for loading data into Dataflow. If you are using a proxy in your environment, you can specify the proxy hostname, port, username, and password in the proxy section. Once the connection object is defined, you can create a run job. Start by selecting the connection object we have just created. Following the connection input, the job requires the project ID and, optionally, the location details. The next field is the job name, which helps us easily identify a specific job. We can adjust the job name based on the functionality or template we are using. If the template does not use any parameters, there is no need to define the parameters field. The JSON file path field allows us to define the path to the JSON file containing the attributes that we want to pass to the application. If the template uses parameters, then the JSON field allows you to enter the JSON payload definition. How do we get the JSON parameter details? For this purpose, let's switch back to the GCP Dataflow console's Create Job from Template section, which we have already explained. Once the required parameters are filled in for the related template, click Equivalent REST in the Optional Parameters section to make the JSON parameters visible. You can now copy and paste the parts you require to your job in Automic Automation. Next is the environment setting. We can choose none for default configuration, specify a JSON file path from your machine, or directly paste JSON content from the GCP console or elsewhere into the text field. For this demo, we use a JSON file. Next, we can define how we want to get the execution logs. Selecting on error only means logs come from the GCP console only when there's an error. Choosing always ensures logs are fetched regardless of the job status. Once all the parameters are set, save and execute the job. Let's switch to the executions view. The Details pane shows the Remote Status field, which tracks the job status in the target environment. In our case, the execution was successful. The Details panel also shows an object variable called and Dataflow job ID hash. It helps us clearly identify the specific job execution, which we can use for further analyses. It also shows another object variable called and Dataflow state hash for the terminal status of the job. The values depend on what the Dataflow server reports back. For example, job state done for successful execution, or job state failed if the job failed. Let's have a look at the reports. There are 4 types of logs available. The first one is the report, which provides all the information that the target system sends to Automic Automation when the job has been executed. The next one is the plog type agent log, which shows all the agent's actions step by step. It lists all the parameters used to run the job and contains the response received from the target system. In our case, once the status reached a terminal state which is shown through the job state done status, Automic Automation concluded monitoring and marked the job as completed. The logs type agent logs are the execution logs from the GCP environment. They provide Dataflow-specific information for the particular job. The met type agent logs contains the Dataflow metrics in JSON format. You can use them for further analyses and checking the metrics for failed or successful job executions. You can also cancel a running execution by clicking on the Cancel button. Similarly, in the GCP environment, canceling the Dataflow job will reflect its status as canceled. Thank you for watching this video.